Okay, now recording. All right, so I was done with 6.2. We're starting 6.3, volumes of a solid of revolution, something called the shell method. Okay, so we'll do shell method. So this method, shell method, quiz on Friday will be on the two methods. Okay, I'll give you a disk problem. I'll give you a shell problem for the quiz. Okay, so again, think every week there's going to be either a quiz or an exam. Quiz, quiz, exam, quiz, quiz, exam, quiz, quiz, exam, and so on. Okay. And you've seen how one quiz works, so the quizzes are all like that. And you know now how to submit stuff to me. Everything you submit to me the same way. Exams, same thing. Homework, same thing. Just get your cell phone and click, 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 take pictures and email to me. All right. So that's what we're at. And the homework assignment is 1 to 19, odd, 37 to 43 odd. And as usual, I'll do a whole bunch of them anyway. When it comes to 6.4, by the way, it's on work. It's almost all word problems. There's like 1, 2, 3, 4, 5, 6, 7, 8 problems. I end up doing maybe 5 or 6 of them anyway. So again, I have that 70% homework requirement, but that's really a joke because I do a great percentage of them. Sometimes I end up doing 70% of the problems anyway. All right, so first thing I'll do is go ahead and show you, for the benefit of those of you that don't have the text and aren't getting it. So the homework is on 6.3. Yeah, there's question 1. Again, I don't plan to show it that long because you can always look at the video and pause, rewind as much as you want. So I'm only going to flash it a quick amount of time, realizing you can always pause and so on. Oops. Okay, there's that. There's that. Let's see. I don't think you had to do that one. And how high did we have to go up to? 43, I guess. So this, we didn't have to do any of these. So 37 to 43, let me aim it so you can see it better. Okay, you should be able to see all the problems. All right, so that's that. And now back to the shell method. All right, so how do you find the volume of a shell? So if you take like a can of soup, can of corn, no top, no bottom, okay, it's very thin. You want the volume of the shell, so not the inside, if you were talking about the meadow, right? So can of corn, no top, no bottom, how much meadow am I using? It's very thin, right? So the way we figure it out is we pretend we cut this and open it up. It looks like a rectangular box, length times width times height. And we said the bottom would be the circumference of the circle, 2 pi r. That's my little thickness, delta r, and this is height. So the delta V, change in volume, is length times width times height, 2 pi r h delta r, circumference times height times thickness. Okay. So in this case, suppose I take the region bounded by f of x, x-axis, x equals a and x equals b, I spin it this way. Okay, so this is not a disk. If I slice this way, delta y, and spin it around, I see a disk. But can you see if I take this thing, if I go like this and spin it around like that, I don't see a disk. You're generating a shell. You're generating something like this. So that's what tells me to use a shell method. In this picture, so I need the radius. In this case, it's a distance from here to here, r, and that's x, right? Distance from any point to the y-axis, that's x. And I need the height. In this case, it's f of x or y, right? Distance from any point to the x-axis, that's y. Okay. And the thickness, you don't usually have to worry about, delta r. It'll either be delta x or delta y. In the integral, it becomes dx or dy. So 2 pi x y dx. Okay, so that's what I showed you last time. And now the other circumstance where you would have the shell is if you have a sliced delta y and you're spinning about the x-axis. So you're going like this. So here x is a function of y. Y goes from A to B. Okay, and I'm spinning like this, so it looks like this. And I'm going around this way, and again, I generate a shell. Okay, if I slice this away and spin about the x-axis, that looks to me like a washer. Okay, like this, take my pen and spin it this way, I get something that looks like this, or more accurately turn 90 degrees, something like that. Okay, so the radius, the thing that I'm spinning about, is this distance. And in this picture, that's going to be y. Here's my height. That looks like it's going to be x. So my delta v in this case is 2 pi yx delta y, or switching around 2 pi xy dy. Okay, so very fortunately, in these two quote unquote simple instances, it ends up being the same formula. You integrate 2 pi xy. You integrate 2 pi xy. The only thing is you can't leave it that way. You can't leave it with two variables. If you have dy, then the only variable you can have here is y. So you just change x to a function of y. And likewise here, you can't leave it like that. You're integrating dx, so you have to change y into a function of x so that it has a bunch of stuff only with x. Okay, now, bottom line, and I highly advise you to put this on your formula sheet for the test, cheat sheet. Basic idea. So I'm playing the game again of, you might say, man, I don't understand anything you were talking about here, anything here. What do I need to pass the test, right? So for the shell method, you're integrating 2 pi rh, okay? Circumference times the height. Okay, and you might say, what happens if circumference times height times thickness? Thickness is going to be either very tiny delta x or delta y. When you integrate, it turns to dx or dy. So normally you don't have to worry about it. Okay, so you're integrating 2 pi rh. So your question is, what's my r and what's my h for the shell method? And a quick reminder for the disk method, you're integrating pi r squared. Okay, so if you want to really compact everything in terms of what you want to do, so section 2, disk method, you integrate pi r squared. You have to figure out what r is. Shell method, integrate 2 pi rh. Okay, so I'm going to show you a bunch of shell method problems now. Okay, so 6.3, page 444, problem number 1. I guess I need to label problem 1. Okay, they showed you the picture. I showed it, but here's y equals x times x minus 1 squared from 0 to 1. How do I get 0 to 1? You just set this equal to 0. What makes this thing 0? 0 and 1. Okay. So I slice delta x. So you see, if it's like this, I spin it about the y-axis, it says, so it's going to go like this, it generates shells. Okay. The disk method, or actually washer, would be if I slice this away. That would actually not be easy. In fact, it would be almost impossible. Then you'd have to solve for x. X is a function of y. It's not easy. In fact, it may be close to impossible to solve this for x. Okay. So we're going to slice this way. So my rule is I'm integrating 2 pi rh. 2 pi is a constant. So what's my r? What's my h? All right, so the radius is the distance from here to here. That's going to be x. Okay, my height is the distance from here to here. Well, that's going to be same as y. Right? I put it in the middle here. I mean, you could talk about anything up here, but if you have any point on this rectangular slice that go like that, that's x. That go like that, that's going to be y. So 2 pi x y, but I don't leave it as y. You can't leave it as y. You're integrating with respect to x. So I have to change y into all this stuff, x times x minus 1 squared. So 2 pi x circumference, 2 pi r. Height is y, and the thickness is dx, tiny little thickness, dx. Okay, so that's the main thing. Once you set this up, the integration hopefully is straightforward. All right, so clean it up, factor out to 2 pi. 2 pi comes out, x times x is x squared. X minus 1 squared is that. I trust you can do that. The square of a binomial, right? A minus b squared is a squared minus 2ab plus b squared. And finally distribute. So that times all three of these. X to the fourth minus 2x cubed plus x squared. Okay. So 2 pi is outside. That's usually going to happen. The 2 pi comes out. When we were doing the disk method, the pi always comes out pretty much, right? So here 2 pi comes out. So let's see, x to the fifth over 5 minus 2, x to the fourth over 4 plus x cubed over 3 from 0 to 1. And you can tell when you plug in 0, you get 0, right? Put a 0 there, 0 there, 0 there, that's all 0. Plug in 1, 1/5 minus 2/4 is 1/2 plus 1/3. Common denominator is 30. So put 30 there. 6 minus 15 plus 10. This is just arithmetic, so I'll fly through this. You can easily get that, right? Multiply by 6 over 6, 15 over 15, and so on. 2 pi over 30. Final answer is pi over 15. Okay, what is that pi over 15? That's the volume I get when I take this funny shape and spin it about the y-axis. It generates this three-dimensional picture, and the volume is pi over 15. Okay. All right, so I'm going to show you a bunch more of these kinds of problems. Okay, problem 5 looks like this. Okay, bounded by e to the negative x squared, y equals 0, x equals 0, x and y axes, and x equals 1. And rotate about the y-axis. Okay, so y equals e to the negative x squared. You say, how do you know what it looks like? Well, it's an exponential type. Otherwise, just plug in nice numbers. You got to plug in 0 anyway. When you plug in 0, you get 1. It says to go to x equals 1. What do you get when you plug in 1? Well, e to the negative 1. You can punch in your calculator if you want. It's about 0.36. But in any event, it goes down like that. So I'm taking this region, I'm tracing it out, and you're spinning about the y-axis. You end up with something that looks sort of like a funny hat, maybe a sailor's hat. Can you imagine that hat? Take this thing and spin it around like that. Okay. And this is the shell method. Again, if I slice delta x, okay, take that thin piece and you go like that, you end up with shells. Okay. The disk method would be slicing, in this case, delta y. If I slice this way, go like that, I have the disk method, but we don't want that here. I have to solve for x. That's going to be a little bit of trouble. And not only that, it isn't consistent. You would have to break it up into 2 pieces because you'd have this part here for part of the problem, and then you have this part here. So in this case, it's a lot easier to use the shell method. Okay. Now, when you have this so-called easiest case scenario, you have a function just going from 0 to 1, and you're revolving about the y-axis. It's pretty much just integrating 2 pi xy. Okay. The radius is x, the height is y. So 2 pi x y, but I don't leave it as the letter y since you're integrating with respect to x, right? You shouldn't have any y here. So what is y equal to? E to negative x squared. Okay, I took out the pi. This is going to be a u substitution. At the end of Calc 1, we did u substitutions. Okay, I don't like e to the negative x squared. I like it to be e to the u. What's the derivative of negative x squared? Negative 2x. Okay, I see a 2 and I see an x, so I just put in a negative 1 inside and outside. Okay, so I'm going to make a substitution. U equals negative x squared. That way I'm integrating e to the u. Du, the derivative of u, is negative 2x dx. Remember doing that at the end of Calc 1, perhaps? Du is negative 2x dx. In the original problem, pi is outside. There's the 2. That's an x there. 2x dx. I need a negative 1. Just put negative 1 inside, negative 1 outside. Okay. By putting these two things by my pen, I'm multiplying the integral by 1 in the form of negative 1 times negative 1, which means I'm not changing its value. But I need the negative 1 here so that I can change all of this stuff to du. So the negative 2x, okay. Somehow I seem to have gotten frozen here. I can't move this. Okay, it's got negative 1 times 2x dx. And I can move my head, but for some reason the screen is frozen. So I'm going to have to stop the share and try to start over again. If not. Okay, so let me cut that off and try to go right back in and see if it works. It's not working. Okay, so I guess we are having technical difficulties. So you can rest for a moment while I try to figure this out. I might have to close this session and start up again. But at least you get a nice little rest. That's not working. Okay. So that doesn't work. Unplug and plug back in. Let me try this. Ah, okay. Looks like we're back in business. I hope. All right, so u equals negative x squared, du equals negative 2x dx. Now, we're going to change the limits also. So this is x equals 0, x equals 1. I need to find out what happens to u. So if I plug in x equals 0 right here, u is 0. I plug in 1, u is equal to negative 1. All right, so now my integral becomes e to the negative x squared is e to the u. Negative 2x dx, negative 1, 2x dx is now du. I got a negative pi outside, pi times negative 1, negative pi. U is going from 0 to negative 1. Okay. Remember, I'm changing the limits from x to u. U goes from 0 to negative 1. That's backwards. You might recall at the end of Calc 1, you can switch these around and apply the negative. Okay, so take out the negative pi, make it positive pi, put the negative 1 down here and the 0 here. Remember that rule in Calc 1? Okay, the integral from a to b is the opposite of the integral from b to a. So that works perfectly. Take off the negative, make it positive, turn these two around, and now the bottom number is here and the bigger number is here. All right, so now we're good to go. So pi times the integral of e to the u is itself, e to the u, from negative 1 to 0. So that equals pi, plug in 0, you have e to the 0, which is 1, minus plug in negative 1, e to negative 1. So that's my final answer right there. Okay, next one I was going to show you is number 7. And these are right off the homework. Okay, y equals x squared, y equals 6x minus 2x squared. And again, from the direction we're spinning about the y-axis, we're still going like that. Now, this time, they don't tell me where to integrate from. Here they told me to go from 0 to 1. Here they don't tell me, so you have to show me. How do I know what the region is? Set them equal to each other. You might recall that was one of the themes of the first quiz, right? Some of you directly integrated from 0 to 2, but I don't know how you got that. You need to show me that. Okay, I don't accept, I got it on the graphing calculator, right? You have to show me that. So the technique is to set them equal. X squared equals 6x minus 2x squared. Do a little bit of algebra, add 2x squared to both sides. 3x squared minus 6x equals 0. Factor out to 3x. 3x times x minus 2 is 0. So x is equal to 0, or x is equal to 2. So plug in 0, 0, 2, 4. Double check 0, 0 works, 0, 0 works. 2, 4. This one's a little harder. 2, 6 times 2 is 12. Minus 2 times 4 is 8. 12 minus 8 is 4. Yeah, it works. Okay, I know this is a parabola which opens up. I know this is a parabola which opens down. So this must be the picture. Okay, so I have this thing here, and I'm spinning this crazy thing about the y-axis. Okay, and I'm trying to find a volume of taking this thing and spinning about the y-axis. Okay. And by the way, you might say, I can't even visualize that. I can't necessarily visualize it either. It doesn't matter whether you can visualize it or not. Okay, we're finding the volume of that thing. Right, so circumference times height times thickness. The thickness is delta x. Okay, from this particular slice, this is the radius, it's still going to be x. What's my height? Well, I'm not going from here all the way down to the x-axis. I'm going from here to here. So it's this height minus this height, or you could even say y2 minus y1. or bigger height minus smaller height, upper minus lower. So the height is 6x minus 2x squared minus x squared, upper minus lower, or 6x minus 3x squared. So that's what I have. Okay, so again, we're integrating 2 pi r h. So my radius is from here to here, x. Distance from any point to the y-axis is x. Here's my height. This height is like y2, 6x minus 2x squared. This is y1, x squared. So the difference is going to be 6x minus 2x squared minus x squared, 6x minus 3x squared. Okay. So ready. Circumference, 2 pi x, times height, 6x minus 3x squared, times thickness. Thickness you don't usually have to worry about. It's just going to be dx or dy. I'll show you a dy case shortly. Okay, take out the 2 pi, distribute the x, 6x squared minus 3x cubed. That's a 3 there. 3x cubed. All right, so 2 pi, 6x cubed over 3, 6x cubed over 3, 6 divided by 3 is 2, minus 3x to the 4th over 4, from 0 to 2, that's a 0 there. Looks like there's a splotch somehow. Plug in 0, you get 0, that's nice. Plug in 2, 2 times 8, 16, minus 3 times 2 to the 4th is 16, 3 times 16 over 4. So let's see, 3 times 16 over 4, 16 divided by 4 is 4, right? And 3 times 4 is 12. So it's 2 pi times 4, final answer is 8 pi. So I have 8 pi as my final answer. Okay. Now, we have a set of problems, 9. Use the method of cylindrical shells to find a volume by rotating the region about the x-axis. We're spinning about the x-axis. That's going to be like this. So my slices are going to be delta y. I'm going to go like this. So I'm going to try to integrate this way. Okay, if we're doing the shell method, it's like this. You can put stuff like this on your cheat sheet if you wish. If you want to put this on your cheat sheet, if you want to put this on your cheat sheet, that's fine. Okay, x, y equals 1, x equals 0, x equals 0 is the same as the y-axis, y equals 1, y equals 3, y equals 1, horizontal line, y equals 3, horizontal line. Spin it about the x-axis. That means my slice is going to be delta y. If I slice this way, delta x, that would be the washer method. Okay, it's a disk minus a disk, but this will be a shell. So I need to write x as a function of y. By the way, this is y equals 1 over x. That's how I knew quickly it looked like that. Right, divide by x, you have y equals 1 over x. Maybe I should write that down, y equals 1 over x. And then you should say, oh yeah, I know it looks like that, roughly. Okay, writing x as a function of y, x equals 1 over y. Okay, so how far is it from here to here? This is the radius. That's what we normally call y. Right? Distance from any point to the x-axis is y. Height from here to here, that's my height. Well, from any point to the y-axis, that's x. And what is x? 1 over y. Height is x or 1 over y. All right, so circumference, 2 pi r, in this case, 2 pi y, times the height, x, 1 over y. Thickness, delta y, and the limit becomes dy. Okay, so circumference times height times thickness. And look at what happens. Y's cancel out. Take out the 2 pi. You're integrating 1. What's the integral of 1 dy? Well, it's just y. 2 pi times y from 1 to 3. Leave the 2 pi out. Plug in 3, you get 3. Plug in 1, you get 1. 3 minus 1 is 2. So 2 pi times 2 is 4 pi. So my answer for this one is 4 pi. Okay, so circumference times height times thickness. Circumference 2 pi r. R is y. Height is x in this case, but what is x equal to? 1 over y times the thickness, delta y. Okay. All right, make that disappear. And 11. Y equals x to the 3 halves. Y equals 8. X equals 0. X equals 0 means y-axis. Y equals 8 is way up here. How do I know what the graph looks like? Well, I can just plug in stuff. They tell me y equals 8. So one thing I could do is solve for x. If you have y equals x to the 3 halves, you can raise both sides to the 2/3 power, right? Like this. Y equals x to the 3 halves. Raise both sides to the 2/3 power. That way the 3 halves cancel to 2/3. So x is equal to y to the 2/3. Sorry, this looks funny. This is x equals y to the 2/3. Now they tell me y is 8. Plug in 8. What is 8 to the 2/3? Well, 8 to the 2/3 means take the cube root. Cube root of 8 is 2, and then 2 squared is 4. So this is the point 48. 0, 0, 4, 8 looks like that. Okay, and now we're spinning this thing about the x-axis. So it looks kind of weird. If I spin about the y-axis, I can kind of recognize that. That looks like a bowl. Can you see the bowl? If I take this thing and spin it this way. But if I take this thing and spin it this way, you get some really weird shape. I don't even know how to describe it, right? But that's what we're doing. So to do the shell method, I slice delta y. So I need the height and the radius. Height is here to here. This is a typical slice. That's just x. This is from any point to the y-axis is x. If I take this thing, spin it like this is my radius. That's y. Distance from any point to the x-axis is y. So here we go. 2 pi RH. Circumference 2 pi r. Radius is r. Times the height. Y to 2/3. Times the thickness dy. So that's what I have for this one. Okay, take out the 2 pi. Y to the 1, y to the 3/3. Pretend it's y to the 3 over 3 times y to the 2 over 3 is y to the 5 over 3. Okay, so 2 pi comes out. Y times y to the 2/3 is y to the 5/3. Right? Remember, y is like y to the 1, treated as 3 over 3. 3 over 3, 2 over 3, 5 over 3. All right, power rule. Add 1. 5/3 plus 1, 5/3 plus 3/3 is 8/3. Y to the 8/3 divided by 8/3 means multiplied by 3/8 from 0 to 8. Okay, let's see. 2 cancels the 8, giving me a 4. So 3 pi over 4. 8 to the 8/3 minus 0 to the 8/3. 0 to 8/3 is 0. Okay, 8 to the 8/3 is 256. It means take the cube root of 8. Cube root of 8 is 2. And then 2 to the 8th power, 256. Okay, so 256 times that, 192 pi. And yeah, just leave your answer as 192 pi. Usually you're not going to multiply out pi is 3.14, blah, blah, blah. Just stop right there. Okay. Okay, now it's harder. We're not spinning about just the x-axis or y-axis, but about somewhere else. 15. Use a method of cylindrical shells to find the volume generated by rotating blah, 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 blah. Okay, 15, y equals x cubed, y equals 8, x equals 0. Spin it about x equals 3. Okay, y equals x cubed, looks like that. There's a branch over here also. Y equals 8 is over here. We did that in the last problem also. X equals 0 is the y-axis. So this is the piece. And I'm spinning about x equals 3. I'm taking this thing and spinning it way out here. So my radius, if I take this slice, this thin slice like that, I'm going like this. Here's my radius. How do I find that? Well, from here to here is 3. From here to here is x. Okay, we're given a point on a rectangle. If I go back to the y-axis, that's x. Therefore, this must be bigger minus smaller, 3 minus x. Okay, this is 3. This is x. This is the difference. Radius, 3 minus x. Now the height, upper minus lower. This is 8. This is y, which is x cubed. So this is the difference. 8 minus y, or 8 minus x cubed. Okay, one more time. I just want this slice here. If I go from here to here, that's 8. From here to here, it's y. But what is y? X cubed. So this is the difference between the two. 8 minus y, or 8 minus x cubed. So volume is 2 pi 8 minus x cubed, 3 minus x. Radius, height, 2 pi 8 minus x cubed, 3 minus x. Okay. By the way, if you can fit it on your cheat sheet, you're welcome to put down sample problems on your formula sheet. 2 pi comes out, FOIL this out, right? 24 minus 8x minus 3x cubed plus x to the 4th. Okay, I got to go back up, but that's going to be 24x minus 8x squared over 2 minus 3x to the 4th over 4 plus x to the 5th over 5. Okay. Plug in 0, you get 0, 0, 0, 0, 0. Plug in 2, 24 times 2. Plug in 2, 8 times 4 divided by 2, 16. Plug in 2. Let's see, 3 times 16 divided by 4. 3 times 4 is 12. Plug in 2, 32 over 5. Okay. Some messy arithmetic. 48 minus 16 is 32, minus 12 is 20. 20 plus 32 over 5. Common denominator is 5. 20 is 100 over 5. 100 plus 32, 132 over 5. Final answer, 264 pi over 5. Okay, number 19, and I think that's the last one I was going to do. I know there's a lot of stuff going on. Okay, so you want to go back and review the videos. Try to see if you can mimic what we did in class. So when you go back to the problems, you're welcome to write it all over, but see if you can do it by yourself, so to speak. And if you can't do it by yourself, go back and look at the video or look at the notes that we did in class and see, oh yeah, that's how we did this or whatever. Okay, so what time is it? Got 15 minutes left. So 19, and I was going to stop with that one. X equals 2y squared, y greater than or equal to 0. X equals 2, spin about y equals 2. X equals 2y squared There's a parabola opening to the right, but it says y is greater than or equal to 0. So I'm going to take this part, and x equals 2 is over here somewhere. All right, so I have this piece, and I'm spinning it way up here. So my slices are going to be delta y. Let's see, how do you know? If I slice this way, delta x, and I spin it way up here, imagine I draw something like so, and I spin it up here, I see discs, or more accurately, washers. Like this, that's where I see the shell. I see the can. So the slice is delta y, and I'm going like this. I'm spinning it about a can. So that's my radius. That's my height. Okay, radius. This is 2. This is y. Therefore, this is 2 minus y. Okay. My radius is here, one more time. This is 2. This is y. This is 2 minus y. 2 pi r. Height. Well, it's upper minus lower. Upper is 2. Bottom is 2y squared. It's like x2 minus x1. This whole distance here is 2. This distance here to here, it's x, like 2y squared. So the distance from here to here is 2 minus 2y squared. So circumference times height times thickness. Circumference, 2 pi r. 2 pi r is 2 minus y. Height, 2 minus 2y squared. Thickness, dy. And let's see, y is going from 0 to 1. And that's the main thing, right? The rest is just messy work. Take out the 2 pi, FOIL this out. 4 minus 4y squared minus 2y plus 2y cubed. Yes, I believe I can just fly through stuff like FOIL. You already know how to do that. So that's why I'm going to go somewhat quick on this. Then I say, okay, you know how to go from here to here. Just check later that you actually can do that. All right, then integration. 4 becomes 4y. Negative 4y squared becomes negative 4y cubed over 3. Minus 2y squared over 2 is minus y squared. 2y to the 4th over 4. From 0 to 1. Plug in 0, you get 0. I just quickly put 0 there, right? 0 minus 0, it's 0. Plug in 1, 4 minus 4 thirds minus 1 plus 2 over 4 is 1/2. Common denominator is 6. Leave the 2 pi alone. 24 over 6 multiplied by 2 over 2, 8 over 6 multiplied by 6 over 6 minus 6 over 6 plus 3 over 6. 24 minus 8 is 16. 16 minus 6 is 10 plus 3, 13. And yeah, that 2 will cancel with that 6, leaving me the 3 in the bottom. So final answer is 13 pi over 3. Okay, so there's a lot of stuff going on in these problems. Fortunately, I did a lot of the problems that were assigned. Okay, so your object is go back and try to do the other ones, but I've already done quite a bit, maybe half, maybe even more than half of the ones that were assigned so far. So go back and see if you could mimic what we did for these problems. When I give you exams, the exam problems are just like the homework. They may not be the very same problems, but just slight modifications of how they work. Okay, so I showed you a lot of problems here. So tomorrow I'll show you a lot more of these. So schedule-wise, I think we're still on schedule. So 6.3, I did a bunch of problems. I'll do some more problems, 6.3. Friday's quiz will be on 6.2 and 6.3. This, I'll give you a disk and I'll show you a shell also. And now that you've seen one quiz, you know, all the quizzes are going to be like that. And how you turn in stuff is all the same. So homework, same thing. Take pictures on your cell phone, right? Just click, 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 email or scan to me. And same thing for the exams. They're going to work that way also. Okay, I'm done, folks. Let me stop the share and check the chat. So your object is to go back and see if you can do a lot of problems that were here. Okay, any questions, please? I'll check the chat. All right, I see nothing or hear nothing, so we're done for the day. All right, so bye, everybody. Have a good day, and we'll see you tomorrow.
Thank you, Professor.
All
All right,
Bye.
take care, Professor.
Bye. Have a good day.